Hello, my name is Hergys Rexha. I'm from Albania and I'm currently doing my PhD studies at Åbo Akademi University. I'm currently researching energy efficiency in multi-core architectures. Energy consumption is a major problem in today's ICT sector in different domains of computing system, from smartwatches to big computers located in data center. And especially energy efficiency is a major problem for the usability, extendability and reliability of such system. I'll start by showing a graph that measures the electricity footprint of the ICT sector from years 2010 to 2030. And we have the forecast for three different scenarios: the best case, expected case, and worst case. Worst case is on top, and the best case is on the bottom. So we see that on the worst case, we have an exponential increase in the future of the electricity consumption of the information and communication technology sector. On the graph on the right, we have the share of electricity which is produced by fossil fuels from different countries. So we see that there are countries which rely mostly on carbon fuels, like South Africa, which is more than 90% production of electricity in fossil fuels. And the world average also is beyond 60% nowadays. Of course, there are countries like shown in the graph, Finland and Sweden, which are trying to lower that share. As an example of activities which are now on the spotlight for high levels of energy inefficiency, there is the Bitcoin, which is a digital currency, as you know, very trendy nowadays. But for producing that currency, the amount of computing work that is needed is very high. And most of the time, these computers are highly energy inefficient. As you can see on the graph on the below right, we have shown the Bitcoin energy consumption through years from 2017 to 2020. And as you can see, the energy related to this activity is growing, and it's growing linearly. On the graph on the top, you can see the Bitcoin activity compared to the other countries' total electricity consumption in 1 year. So you can see the Bitcoin is 33rd in the graduatory and consumes more than Netherlands and consumes a lot more than Finland, which is between 90 and 100 terawatt hours per year. Another example of today ICT activities which is forecasted to consume a lot of energy is 5G technology. A strong push for 5G technology comes from the industry. There are many applications which require nowadays different characteristics of the mobile connectivity. So more bandwidth, lower latency, lower power consumption per bit transmitted. And 5G in the future will come and will bring many other new applications which will run on the edge of the network. Why is 5G a problem related to power consumption? As you can see from the graph, base station implemented that will support 5G will consume more than the previous 4G plus technology, which is like 68% more power. So it is estimated that only in China, once 5G is deployed, it will consume 100 billion kilowatt hours more per year, which is, if it is translated into carbon emission, it will be like 27 billion kilograms. My research is focused on today's modern chips, which offer the possibility that inside a chip to have many computing elements that are different from each other, which we call cores. And modern chips today have different type of cores. We call them simple, medium, complex, according to their performance, to their energy consumption, and to their complexity. So in our research, we focus on dividing this cores into groups and providing different configuration inside the chip. each configuration would provide a certain level of performance and a certain level of energy efficiency. So we'll be able to place our workload on the proper configuration in order to have the best energy efficiency solution for our need. As an example, I would like to point out the mobile workload example. In our mobile phone, we have today a different application. Of course, each application has its characteristic regarding the needs for computing elements. For example, we have HD games, which require huge computation. They require complex cores, which are very performant. But then we have social media application, which can stay on the background of your phone and just do some random checks. But they can simply use the simple core, which are highly energy efficient. So why to use one gear for driving in every condition in the road? So here we can use also one core, which is appropriate for each application type. And the heart of our research is shown in this picture. We have the runtime system, which is the manager of this application. This runtime system senses the needs of the application for performance. And according to some power models, it places each application into the right configuration of the hardware for achieving the best level of energy efficiency. And if the temperature of the chip or of the device will change, this runtime system will reconfigure itself and will reconfigure the place of each application in the hardware. On the network domain, or let's say on the telecom domain, we have a system which is continuously monitoring the network equipment and gathering live usage data. And these data are a valuable source of information for placing the computing systems into high energy efficiency state. So with this data, we can train intelligent engine, which then will manage the network and computing equipment. So at the end, we can say that by applying this runtime reconfiguration of the workload and by taking into account the thermal condition, we predict to increase the energy efficiency by 1/3. And we also tend, or let's say we want to increase the edge system energy efficiency in order to make better usage of the computing infrastructure. And experience-wise, the PhD's journey of the research was quite interesting and stimulating for me. Thank you.
Hergys, thank you very much for your presentation. You showed some remarkable scenarios of energy consumption or power consumption in the ICT sector in the future. In your own work, you gave an impression that you could help cutting that trend. To what extent, if your work goes well, how much can you improve the power consumption in these 5G systems?
Yes, according to our test and to our measurement, we target to achieve about 1/3 in improving the energy efficiency of computing system. Of course, it has its variabilities, but yeah, I mean, most of the time, if we target this heterogeneous environment, I mean, we can achieve that kind of reduction in consumption and improvement in energy efficiency.
What is the real challenge there? What makes it so hard to do that?
The problem is that in today's chips, there are many configurations possible of different actuators. So you can move knobs here and there, and in a certain point you define a configuration. But in assessing the energy efficiency of that configuration for a lot of applications that exist out there, it's kind of very difficult. So you need to do a lot of profiling and a lot of tests. And today there is artificial intelligence which is working hardly there in order to predict which will be the most efficient way to map a certain application to the hardware.
And how far are you with your PhD now?
Hopefully I'm at the end of it, so now I should be writing my thesis. Yeah, and I have all my publication done, and I need to wrap up the thing and just go.
Good luck with the wrapping up.
Thank you very much.